Assalamualaikum to my panels. My name is Abdul Mujeeb bin SOHPIAN. My supervisor's name is Encik Muhammad SAIFUL Bahari bin SHAARI. Today, I would like to present to you my final year project presentation titled Monitoring Hydrostatic Pressure Using IoT. So before I start my presentation, let's look at the table of content. This slide will go through project summary, introduction, methodology, expected results, and reference. Project summary. Oil and gas industries require detection and localization of anomalies in the pipeline structures. Pipeline damage and impairment can be caused by a variety of factors. This harm is directly related to asset and human safety in the chemical and petroleum industries. As a result, continuous monitoring and a rapid response are anticipated. Hence, this paper provides a real-time integrity inspection of hydrostatic pressure test monitoring using Internet of Things. Blink and ThinkSpeak solution that may be applied to this monitoring is deliberated and evaluated. Introduction. Pipeline integrity is the foundation of many industrial and engineering systems. Pipeline integrity management includes pipeline assessment, inspection, failure prevention, repair, and maintenance. However, integrity management focuses on various system components based on the type of pipelines. For example, oil and gas pipelines fall into high pressure pipelines category, where the internal pressure of the pipeline is very high. In this project, we are focusing on improving digitalization of the result. We are incorporating the IoT so that the result will be online, available for remote monitoring. This project is sustainable towards environments where it prevents any leakage or damage pipeline before installation. In terms of social sustainability, this project reduced the number of casualties due to mishap during pipeline testing. Lastly, towards the economic aspect, this project contributes less cost of operation and offers higher productivity towards pipeline inspection. Literature review, I took one example of journal article that I had written in the proposal. The article journal with the title Petroleum Pipeline Monitoring Using an Internet of Things that was published on 23 January 2021. They explore the use of Internet of Things analytics to mimic a real-time pipeline monitoring and determine the location of damage on a pipeline. In the research, they utilize Arduino and Wi-Fi module to detect pipe leakage using hydrostatic pressure. The outcome of the study was a success to project a real-time monitoring of a pipelines. This case study differs from the previous work in a certain aspect. First, this project is more focusing on the pipeline integrity before the fabrication work of the pipeline. Meanwhile, the previous project was focusing more on maintenance and repairing of the existing pipeline on the offshore. Besides that, the proposed project contribute to ensuring the new pipeline are truly manufactured by strict specification and safe before progressing the fabrication work. Next, this project extends the capability of IoT and networks. This project enabled the result of the test pipeline to be compiled in designed paperwork and can be sent to work authority for verification. In other words, this project simplifies the work and can be directly accessed by responsible engineers for verification process. So based on literature review, this project have identified two problem statements. First, the oil and gas industries were negatively impacted by the high cost of operations due to length duration of hydrostatic pressure tests used to verify pipe integrity. Next, many accidents occur in exploded pressure during this test. Hence, this project is to investigate the alternative to cost cutting through IoT and ensure safety for performing hydrostatic tests. This project has three objectives. First, to digitalize and monitor the pressure sensor using an IoT application. Second, to reduce the operation cost by improving worker productivity. Lastly, to maintain the safety of workers during hydrostatic test execution. The project scope focused on developing an IoT pressure sensor using microcontroller ESP32 to be used for remote monitoring hydrostatic pressure tests. Next, this project will be carried out in two situations: when conditions are under pressure to be maintained and when conditions are dropped. Lastly, this project will be tested at engineering workshop. Project limitation for this project have three factors. First one, it have contain fragile hardware such as microcontroller ESP32 that could lead to error and system malfunction. Second, it needs a stable internet connection and sufficient power supply. Third, needs a dedicated worker who have basic knowledge about IoT and programming in order to be maintained. Methodology. So here is the project workflow for this FYP. This project will be conducted at 10 bar pressure. Hence, for selection material specification based on ASME and ANSI standard, this project will be used 2-inch diameter with schedule of 40 seamless steel pipe with combination of 5-inch diameter of flange. Both of material have been calculated to sustain in 10 bar pressure. For the pressure sensor connection to ESP32, here are the schematic wiring diagram to show how it will be connected. Red and green wire will be connected to power source by go through converter from AC to DC in order to function. Lastly, for the output signal, this pressure will transmit 5 volt to ESP32 to analyze the data. So, on this slide, it will tell us about how the hydrostatic pressure will be conducted. After insert the bolt and the nut to flange, then it need to seal hydraulic to protect any leakage. Next, the water will be filled into the pipe before the valve is shut off. Then, the pipe will undergo pressure filling until it reach desired setting pressure. Then, the pipe will undergo hydrostatic pressure test for 1 hour. After finishing the test, the seal is opened to let the water pass through. Lastly, remove bolts and nuts in order to remove the tool. Expected results. So, here is the estimation cost breakdown for this project to commercialize. The point that we need to highlight is engineering and design. Engineering and design I estimate in 5,000 ringgit. This is because it includes the manpower, calculation, and product design that suit to client requirement. Next, this breakdown cost also includes testing and training fee that may be given after purchasing this product. The warranty for this product is 1 year, and in terms of maintenance, it will be calibrated once every 12 months. This table compares productivity hydrostatic pressure test using the current method and digital method. As observed in the table, the duration of hydrostatic pressure was not affected that extend the delay or drag time. Instead, the verification from internal and client QA/QC took the longest duration throughout the process. Thus, this project will convert all the hydrostatic procedures, including the verification process, using IoT and cloud network to shorten the testing and verification process. So, in this slide, we will see the front view and the isometric view of product preliminary design. Reference.